In this tutorial, we are going to find the inverse Laplace transform of f of s, which is equals to exponent of minus 2s times s divided by s minus 3 squared plus 25. So given that function there, f of s, I'll start by factoring out the exponent of minus 2s there, and then rewrite the 25 as 5 squared. And therefore, we would have exponent of minus 2s times s divided by s minus 3 squared plus 5 squared. And then we go on and look at that function there. And then compare it with functions in the table f of s. We see that it is closer to those two functions there, f of s, s minus a divided by s minus a squared plus b squared, and the other one b divided by s minus a squared plus b squared. So it is almost close to those two functions, but it's not in that form exactly. So what we can do is we can try to rewrite that function there. Because in the first f of s, which is above there, it is an s minus a. See that our a there would be a 3. So we try to introduce a 3 there in the function that I've highlighted on the left there. And if we introduce a 3, that is, we put a minus 3 in the numerator there. But since it was not there initially, it will be minus 3 plus 3, which is a 0. So it will be exponent of minus 2s times s minus 3 plus 3 divided by s minus 3 squared plus 5 squared. And this is just because minus 3 plus 3 is 0. So what we have done there is just equivalent to adding a 0, which does not change the function itself. And we can go on and then split that to write it as two functions there. And we have exponent of minus 2s times s minus 3 divided by s minus 3 squared plus 5 squared. And then on the other part where we would have that other 3, we would have exponent of minus 2s multiplied by 3 divided by s minus 3 squared plus 5 squared. So I'll go on and rewrite the first part. We just take it as it is. But looking at this part there and comparing it with the ones that we were having in the table, we are having a 5 squared. And in the table, it will imply that we would have a 5 in the numerator there. So what we need to do is we need to remove that 3 and have a 5. And to achieve that, what we can do is we can take that 3 outside those parentheses and then put a 5. But since we have a 1 when we factor out a 3, to cater for that 5 which we would have introduced, we would have to divide that whole section by 5. So when you do that, we get the expression 3 divided by 5 multiplied by exponent of minus 2s times 5 divided by s minus 3 squared plus 5 squared. So we have now rewritten the f of s there. And when it is in this form, we can try to now look at the inverse Laplace transforms of those functions in the parentheses. And to do that, we would use the table of Laplace transforms. So looking at that function there, s minus 3 divided by s minus 3 squared plus 5 squared, we see that it is of the form s minus a divided by s minus a squared plus b squared. By comparison of those two highlighted functions, we see that our a is a 3, our b is a 5. So if a is 3, b is 5, we now substitute those values of a and b into the f of t, which is to the left of that highlighted f of s in the table. And we would get the inverse Laplace transform of s minus 3 divided by s minus 3 squared plus 5 squared is equals to exponent of 3t times cosine of 5t. So that's what we have there. And we move now to this function now that I've highlighted. This one we see that it is of the form b divided by s minus a squared plus b squared. And by comparison of those two highlighted functions, we see that our a is a 3 and b is equal to 5. We go on and substitute these values of a and b into the f of t, which is to the left of the f of s in the table there, the exponent of at multiplied by sine bt. And to obtain that, the inverse Laplace transform of 5 divided by s minus 3 squared plus 5 squared is equals to exponent of 3t multiplied by sine of 5t. What we have found there are the inverse Laplace transforms of the functions which were in the parentheses. But our f of s there is having a term where we have exponent of minus 2s. To find the inverse Laplace transform of our terms where we have the exponent of minus 2s there, we would have to use another formula in the Laplace transform tables. And the formula that we use is the one which is appearing right at the end of that table, the one at the bottom there, where we have exponent of minus cs times f of s. So looking at this function there, now considering it with the exponent of minus 2s, we see that it is of the form the exponent of minus cs times f of s. And by comparison, we see that our c there is a 2. And if c is a 2, what we then go on and look at is the f of s there. Both the f of s, we had already obtained the f of t. We said the inverse of the part which is in the parenthesis is exponent of 3t cosine of 5t. So what that means is the f of t there is exponent of 3t multiplied by cosine of 5t. But in the table there on the left, we are having f of t minus c. And we have said our c is a 2. So our f of t minus c will be f of t minus 2. And what we are doing is we are replacing wherever we are having t, we are putting t minus 2. And we would have exponent of 3 times t minus 2 times cosine of 5 times t minus 2. And then go on and apply this formula there, h of t minus c. So what we are having there from the tables there, the inverse Laplace transform of exponent of minus cs times f of s is h of t minus c times f of t minus c. And we are saying that our c is a 2. Then we substitute the f of t that we have just obtained above there. We would have the inverse Laplace transform of exponent of minus 2s times s minus 3 divided by s minus 3 squared plus 5 squared is equals to h of t minus 2 times exponent of 3 times t minus 2 times cosine of 5 times t minus 2. So that's the inverse Laplace transform of the function that is highlighted on top there. We can now move on to the other part of that f of s. So what we look at is this part now, exponent of minus 2s times 5 divided by s minus 3 squared plus 5 squared. So again, we use the formula which is on the bottom there. It is the exponent of minus cs times f of s. By comparison, we are seeing that our c is a 2, just because we are having exponent of minus cs, and in our function we are having exponent of minus 2s. So if the c is equals to 2, we now go on to our f of t. Our f of t, we obtained it as the inverse of 5 divided by s minus 3 squared plus 5 squared. And that inverse there was exponent of 3t times sine 5t. Therefore, what you are having there is our f of t there is exponent of 3t times sine 5t. And we need to evaluate f of t minus c. We are saying our c is 2. So f of t minus c will be f of t minus 2. And we are substituting t minus 2 wherever we have t. And we'd have exponent of 3 times t minus 2 times sine of 5 times t minus 2. And we then go on and use that formula there at the bottom, which says that the inverse of exponent of minus cs times f of s is h of t minus c times f of t minus c. Our c is a 2, so we'll substitute it where we have the h of t there, minus c, and we'd have h of t minus 2. And our f of t minus 2, we have already found it above there. So we would have the inverse Laplace transform of exponent of minus 2s times 5 divided by s minus 3 squared plus 5 squared is equals to h of t minus 2 times exponent of 3 times t minus 2 multiplied by sine of 5 times t minus 2. So that is the Laplace transform of and that part there. But now we want to find the Laplace transform of that combined function, the f of s, which is on the top. And that is, we add those two inverses that we have just obtained. But for the second one, remember there's a 3 over 5. So we multiply the second one there by 3 over 5 there. So therefore, the inverse Laplace transform of exponent of minus 2s times s divided by s minus 3 squared plus 25 is equals to h of t minus 2 times exponent of 3 times t minus 2 times cosine of 5 times t minus 2. Then plus the inverse Laplace transform of the second one there. But we put that term, the 3 over 5. So it will be 3 over 5 times h of t minus 2 times exponent of 3 times t minus 2 times sine of 5 times t minus 2.